Hello and welcome to our, what are we on now? Sixth session. Yes, our sixth session. And this one, we're going back to statistics for a little bit. So there we go. Just waiting for a moment for my screen to make sure that it is showing. Hopefully in 2 seconds. There we go. All right. If you cannot see it, please just let me know in the chat. But I'm assuming that it is now showing. All right. So today we're looking at histograms, cumulative frequency, and box plots. So I'm going to start with a little bit of just some information about what they are, what we're looking for, and then we'll do some exam questions. So to start us off, what is the 5-number summary for a box plot? So what are the 5 key pieces of information that we need when we're doing a box plot? Put your answer in the chat, and this just lets me know that the chat is going and everyone can hear me and everything is working. In the meantime, I'm Ashley from Miss IB Maths, this one over here, in collaboration with Exam Dojo for these exam bootcamp sessions. Anyone know what the 5-number summary is? Anyone at all? Or another way to say it is the 5 pieces of information that we need to draw a box plot. Maybe you haven't heard of it as the 5-number summary, but the 5 things we need for drawing a box plot. All right, I'll start us off. We'll go through this as well. We need the minimum value. That's our first. We need our quartile 1. We need our median. We need our quartile 3. And we need our maximum. Those 5 pieces of information we calculate, and then we can draw the box plot. We will do some more of that later. So to start us off with the formula booklet, it's always good to know what you are working with, what you have, what you've been given. For this topic, there's actually not much. So there's a few things that you just need to remember beforehand. So there's the formula for the interquartile range. That one's not as helpful because hopefully we all know what that is. They also give the mean formula, which looks pretty horrible, I must say. I don't know if anyone has ever used that formula to calculate the mean because it just looks pretty horrific. But we, by this stage, hopefully all know that the mean is the sum of all the values divided by how many there are. So that's what this is saying. This notation, the Greek sigma, is the sum of all the values divided by n, how many there are. So I think this formula is not necessarily the most useful for us. And that brings me to another question, which you can answer in the chat if you know. Which formulas do you need to memorize for this topic? This is something that I would recommend you noting down. So each time you get to a topic that there's a formula you need to memorize when you're studying, to just have a list next to you and just write in any of these formulas, anything you come across that you think, that's not on the formula booklet, and I need to remember that, because right before your exam or the night before, you can quickly scan through all of those things in one place. So it's almost like your additional personal formula booklet. And then you just need to memorize those, scan through them, and then you can be prepared instead of going through each topic, having to pick out what you need. So for our for this topic, we need to memorize the formula for outliers. So that one isn't given. So we have the interquartile range, IQR, times 1.5. And then we either need to subtract that from our lower quartile, let's call it Q1. Q1 minus that, or quartile 3 plus the IQR times 1.5. So for both of them, we need to start out by finding the interquartile range times 1.5, and then either subtract that or add that to find out what values are going to be outliers. So that's the formula for outliers. All right, that's the one that you need to memorize. And then there's a few things about cumulative frequency graphs that you just need to know before starting that often get forgotten. Like, do I use the upper limit or the lower limit to plot it? Or do I use the mid interval value? So those are a couple of things. All right, for histograms, bar charts are not typically something that we see because they're quite basic. They're not really to do with the continuous data that we're looking at. So you're going to be seeing histograms. The main difference between bar charts or bar graphs and histograms is the spacing in between. So you can quite instantly recognize a bar chart when there are spaces in between the bars, and a histogram doesn't have spaces. So that's because this is continuous data. So there's no values that it doesn't take. So if there's gaps in between, then we're assuming that they're not overlapping. But here the intervals are right next to each other with no gaps. And a bar chart would be more for discrete data or qualitative. So things like colors and brands and things like that. Things we don't really see much in the DP course. So we're going to be looking at histograms. So like I said, the main differences between them: gaps between bars, no gaps between bars. Bar charts are for discrete or qualitative, and histograms are for continuous. Then also on your x-axis for bar charts, it's like categories or individual values. So you might have like 1, 2, 3, 4, 5, and your little bars for each of those, or red, green, depending on things like there. And then it doesn't make sense to put them together. Whereas on a histogram, you're going to have intervals. So you'll have data that's between certain values, let's say, like that, and between, say 20. So in our notation here, we have to include one of the values. So here 10, for example, 10 is not included here. It's up until 10, but not included, but that's okay because we include 10 there. So that means it's continuously going through. So that notation is quite important. And sometimes you can also write it like this. And do it rather like that. That's also fine. And luckily, these will be given to you in the exam. Let me just put a difference, either one. They'll give you the class interval. So that's a nice thing that you don't have to think about because that can take time. Like, how many do I need? What should I put the width of them, like from 0 to 10 or 0 to 5? But they will give you that in the exam. Then the bar width. Here, the width of the bar doesn't matter. If I have a red bar that's like that, as long as my green bar is the same size, that's not really the same size, but the width doesn't make any difference to the question. It's not indicating any kind of information to us on a bar chart, as long as they're all the same. Whereas the histogram represents the width of the class. So like we had here between 0 and 10, the width is 10. Or if we have between 0 and 5, the width is 5. And that could indicate to us different things, like how the data is spread. One other thing is a histogram, we can read the shape of the distribution. So this one is giving us the classic bell curve shape, which we talked about in normal distribution. So that's making that classic bell curve shape, which indicates that this histogram, this information, or this data is following a normal distribution. And in histograms, we're not going to have a mode, but we're going to have a modal class. So the exam will say, what is the modal class? They won't say what is the mode. So you need to know that's going to be, you can look at whichever is your highest bar. The highest bar indicates your modal class. Then we also have the shape. So this one, I would say, is quite symmetric. Like if we had to draw a line through the middle and we imagine folding it over, it would match pretty well. So we could say that this one is symmetric, which is generally what we have for a bell curve. You could have one like this, And we call these either skewed left or skewed right. This one, what do you think? Do you think that's skewed left or skewed right? So this one is actually skewed right. And you would think, but the data is mostly to the left. Why would we say that that's skewed right when the data is mostly seem to be more on this side? Well, we're actually, when we're talking about these skewedness, we're talking about the tail of it. Where is the tail? So the tail of it, the shorter part where it kind of trails off, is the part that we're looking at for the skewness. So the tail is to the right, so we say it's skewed right. Then we're looking at spread. Are they mostly concentrated in the middle? Are they spread to like what is the heights of them? And yeah, the last one was whether it's normally distributed, which this one is. So this one is sort of slightly symmetric about the mean, but that isn't the mean. So we'd have to work that out. So we can't say that for that one, even though it looks like it is, it's not. All right, so these are things that the question might ask you to describe the spread of the histogram or explain what's going on. And you have these things. You have the modal class, that will probably be a previous question, and then describe it. And then the shape, the spread, and if it follows a normal distribution or a bell curve. More on this in, I think it was session 2, if you want to go and have a look at normal distribution. That was in session 2. All right, so then we have cumulative frequency graphs. So we're going to be drawing cumulative frequency graphs or reading information from cumulative frequency graphs. And a question can often give you a table like this, and they will put, let me draw in, they will give you another column, usually that you can just write on the exam paper. You have to add your cumulative frequency column. So I'm just going to call that CF for cumulative frequency. So here we have the intervals of the heights. This is all going on the x-axis. Let me put that in a different color. So that our variable there will always go on the x-axis, and our cumulative frequency, not frequency, will go on a y-axis. So if you are in your exam and you're plotting your cumulative frequency graph, and it starts looking like this, sneeze. If it starts looking like that, kind of going up and down, that means you've plotted your frequency and you've forgotten to add the cumulative frequency graph, because a cumulative frequency graph is always going to be rising upwards because you're accumulating the frequency. So it's going to have kind of this shape where it starts off a bit slow, it gets a bit more increasing faster, and then kind of slopes off again. So that's your indication. It happens very often that I see as an examiner the frequency plotted and not the cumulative frequency. All right, so if we want cumulative frequency, we need to take the frequencies and keep adding them. Accumulating means to keep adding on. So first one, just 3. We've added nothing. Then we have 3 plus 5, so we get 8. Then 8 plus 9, we get... So early Saturday morning for me, we get... No, I was right, 17. Then plus 7, we get 24, and then plus 1, we get 25. All right, so cumulative frequency graphs are going to be using these as your y values. So I think I have it below, and then we don't have to graph it. Is it the same one? Yeah. So you'll often have to add that column of your cumulative frequency, and that's all there is to it. And generally the question will say something like there are 25 people in a class, and you need to make sure that you take that note of that, and that's what you end up with. So if you haven't ended up with that same number, then you know that there's a mistake somewhere. So let's see how that would look on a graph and how we're going to plot it. This is the important part. So when we're plotting out points for our x, remember I said that this was the x column, we are taking the upper boundary. not the lower boundary, the upper boundary for our first coordinate. So be all of these ones. We're taking the upper boundaries. And then remember, we're not taking frequency. We're taking, for our y, the cumulative frequency. So all of these values, these are going to be our points. So we're plotting points on this graph. So for my coordinates, I'm going to have 155 and 3. I'm going to have 160 and 8. And 165 going up in 5s each time, 17. 170 and 24. 175 and 25. So these are my coordinates. But one thing that we mustn't forget is that we need our starting point. So your starting point is always going to be, let's do another color. It's always going to be the lower boundary and 0 for cumulative frequency, because we are starting from 0. So it's going to be 150 and 0. That is always going to be your starting point. So a lot of people forget that and just start it from 0, 0. Don't start it from 0, 0. Start it from your lower boundary, because the height, if you're starting from 0, 0, that's going to skew your data. It's not going to be true. So your lower boundary is what you need. So then you'll have all of those points that you'll plot, and then you'll get your cumulative frequency curve. And the important thing is when you get those, let's say we have something like this, 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 to not draw them with like straight line, straight line, straight line. It shouldn't be broken up like that. It should be a smooth curve. So try and do it. It's going to be hard on this, in one smooth line. Like that. Not very like straight line segments. All right, and as we said, cumulative frequency, you can write cumulative frequency here, and here you write height, whatever your variable is. Titles are not important in IB exams. We're looking for labeled axes, so you want to write like a y and an x, and we want labels of what we're looking at, and that's pretty much all you need for cumulative frequency. So let's have a look at what it should look like. This is a proper one. See, we have there 150, that's the lower bound at 0 cumulative frequency, and it's going steadily up. Then there's a bit of an increase, and then it kind of slopes off again. That's very typical of cumulative frequency curves, because most of the data is happening around there. All right. Now, more often than not, you don't actually draw the cumulative frequency curve. It can happen. They can ask you to do it. There have been a few questions, not in a while, if I can remember correctly. Most of them will give you one, and you have to read the information off of it. So let me just zoom in there. I hope I'm not blocking too much because it's quite small. You need to be as accurate as you can be with the exam questions. They don't give many, there isn't like a lot of chance to get things correct if you've taken something like super estimated. You really need to be as accurate as you can with the scales when you're reading off points. Because you might think, well, it's a curve, I can't really see, so I'm going to guess it's sort of around 45, but you have to be like 42.5, even though it's reading from a graph. So they're quite strict about that. And that's why they give you the grid behind, so you can have that to help you. All right, so how we read these off, the quartiles and median and interquartile range, we're going to draw it. So the top of our graph is at 40. You always need to look at this value and not the value that the graph goes up to, because maybe it goes up to 50. It's gone like a little bit extra, but we want where the graph ends. Okay, 40. So that's where my line goes up to, not where the axis goes up to. That can be quite misleading. All right, so 40 is my top. I have a total of 40. Now, let's do the median first. Median is always halfway through the data. So half of 40 is going to be at 20. So we draw a line at 20 until it meets the curve. And that looks like it's following that line. Okay, and where is that? That's in between 40 and 45, so that would be 42.5. So our median is at 42.5. Something that people often get confused with is doing half from here and then going up to read the cumulative frequency. But you always start from cumulative frequency and then read the values, because we want to know the length in centimeters. We're not reading off for a cumulative frequency value. We're reading off to find what is the median length. All right, then again, to find the lower quartile, we need a quarter of this, or an easier way if you've done the median first is just to do half of the median again. Sometimes they're not always nice numbers, so it's easier to do half of the median than a quarter. So that's a 10. That doesn't look like it's exactly on the line. That looks like it's just in front. So if that's 37.5, I would say that's 38. So my lower quartile is at 38 centimeters. And then upper quartile is halfway in between 20 and 40, which is at 30. This is a very nice number, 40. It's very easily divisible into 4 sections. All right, 47.5 centimeters. So there we've read all the information off from our graph. So to find the interquartile range, we're going to take 47.5, our upper quartile, minus our lower quartile, minus 38, which gives us 9.5. So our interquartile range is 9.5 centimeters. So a question might ask you to find maybe median and interquartile range. That's quite common, because then that means that they're asking you to find all of these, in fact, because to get the interquartile range, you need upper quartile and lower quartile. So it's very common that they ask for these two, which means you have to do all of them. Any questions? No. All right, so how this can relate to box plots. Often you'll have to draw a box plot after this, and they'll give you the box plot underneath the graph if you're lucky, or you have to draw it. But it's quite nice and easy, because can you see we've already got all that information here. So I'm just going to continue. Wait, let me put my axes here. For a box plot, you always need a ruler at the bottom. That's going to help give you your scale, because if I just plot a box plot in the middle of the air like this, there's nothing to attach these values. So we don't know if it's skewed. It doesn't give us any information. Like, could it have a long tail like that and look more like that is also possible. That's why we need a ruler underneath with consistent values, so that we are able to really see what's going on and see a shape, because not all box plots are going to look like this perfect one, although mine are quite ugly. So our cumulative frequency curve already has all that data. So if I draw down, this was my quartile 1, this was my median, this was my lower quartile, my maximum. There we go, at 55. Again, maximum is not 60, because the graph is not going up to 60. And the minimum is not 0, because the graph isn't going, the graph's going to 30 like that. So there I have all of the things that I need for my box plot, which is the minimum, lower quartile, median, upper quartile, and maximum. So let me just draw on, no, I don't want that. I want a different color. Let's take blue. So I'm going to draw my points here, just lines. And then with our middle things, our quartiles, we join them up in a box. And then we add our whiskers. These are called box plots or box and whisker diagrams. Might have heard that. Box and whisker plots or diagrams. So these are the whiskers. These are the strings that attach. And there we can have our box plot from our cumulative frequency curve. So that's quite nice. If they've drawn it underneath for you to fill in, you just use what you've already calculated. This also saves time. You don't have to go and replot and recalculate. So that's quite a nice tip. You might see that they have this little squiggly zigzag here. That's to show that the distance between 0 and 30 is not the same as the distance between the rest of the points. So the rest of these are going 5, 5, 5, 5, 5, all the way up. Between 0 and 30, the distance is 30. So that could be misleading if they don't show that. So they have to do that little squiggle, which shows that that distance is different. So it's just a note to us. All right, so as we were saying, 5-number summaries and box plots. If you don't have your cumulative frequency curve and they've given you a whole bunch of data like this, we'll do this in a bit, you need to make your 5-number summary first. So like we said, that was your minimum value. That was your quartile 1, or also known as your lower quartile. That was your median, also known as quartile 2. It's one of the quartiles. Then your quartile 3, otherwise known as the upper quartile, and 5, your maximum. These are what we call the 5-number summary in order to draw the box plot. So once you have this information, then you can draw it on your box plot. So remember, a ruler underneath, that should be much straighter than mine. With equal things here, you've got to decide on what scale you're going to use if they haven't done one for you. And then you draw your box plot. So you'd mark your maximum, minimum, maximum, say, let's make it skew 1. Box, I'm just making this up, but just so you're getting an idea of how it's looking, please use a ruler. And that's how you would draw it from these values. So min, and this is also just information for when they ask you to read off of your box plot. And max. So now a very important question that comes up reading from box plots that a lot of students surprisingly don't know is how the data is spread on a box plot. So between, it's all, let's say there's 100% of the data is in the whole thing, then it's split into 4, right? The quartiles, meaning 4 parts. So we have the data split into 25% sections. And this everyone does seem to know, but they don't seem to know how to apply it to questions. So they'll say something like, they'll give you a value here and a value here and say, let's say that that's 21 and 38. And they'll say, what percentage of the data is between 21 and 38 centimeters? And the idea is that you have to look at your graph and go, well, it's meant to be at my quartile 1, and say, oh, 21 is my quartile 1, 38 is my quartile 3. Well, that means between my quartile 1 and quartile 3, there is 50% of the data. So between 21 and 38, there is 50% of the data. Or if they give you that there are, let's say, 100 people on this, and they say, how many people are between 21 and 38 years old? And then you read that that's 50% of the data, and there's 100 people. So that means 50% of 100, that's going to be 50 people. 50% of the data means 50 people. So we'll practice one of those later as well. But this seems to be quite a common question that a lot of students don't know how to answer. They can read off minimums, they can read off medians, but they don't know how to read off the percentages. But that's all there is to it. When you're given these values, you just have to look at where they are on the graph, and you will see, oh, it's on the minimum, or oh, it's on the quartile 3. So once you know them, they're way easier to answer. So let's, oh wait, no, I wanted to actually show you on a GDC, just to also show you graphing. So I have the TI Inspire, and I think it's similar on all the other calculators, but if you're not sure, just pop me a message afterwards and I can tell you how to do it on your calculator. You can DM me at Miss Ivy Maths. I'm happy to answer any questions you may have about this after this sessions you want to see, anything, just message me. I'm happy to answer. So let's say that we get, I've already put it on here, data. and I need to make a box plot out of it. So I've put in all my x values. All my x values, I put in some frequency. So the number 1 occurs 20 times, the number 2 occurs 23 times. And I've called that my frequency list. So this is just a way that they could give you a table of data, and I've already put it in. But if you go menu, statistics, and this works for any data you're given, stat calculations, we want, in this case, one variable statistics, because I have a frequency list, but that's just for my one variable, like let's say height. One list, just my X list. So my X1 list, that was my X, I'd called it. The frequency list, I'd called my frequency list, which really helps to call it something so you know what it is. And I want the results in the C column because I have this in A, I have this in B, so I want this in C. And I press OK, and there it is. So I get the mean, X bar, with the bar on top is your mean, your average calculated. If you have to show calculations, this is the sum of all your X values. But the most important is down here. See that you get your 5-number summary already calculated for you. This is your minimum value, which is 1, my quartile 1, my median, my quartile 3, and my maximum. So if you have a paper 2 calculator, if you're in AA or in any paper for AI, then you can use this if you're given a table of values and you need the 5-number summary or a box plot or the average. Just a hint that this is a really quick, nice way to do it without making mistakes, as long as you have typed in your data correctly. So that's just a tip. All right, so let's see. We have 19 students who've taken a test and scored the following marks. Luckily, it has already been sorted in order. And I think most of the time they do tend to do that in your exams, because taking time to sort things in order is just a waste of time for everyone, and allows for mistakes. So they've most often done that. All right, so I want to find my 5-number summary for my box plot. Let's do it here. I want my minimum. Helps to write this out. Then it takes out some of your thinking. My quartile 3 and my maximum. Minimum and max, super easy. 23 is my minimum value. 95 is my maximum value. Now, I want quartile 1, median, and quartile 3. Now, my median is going to be n plus 1 divided by 2 through the data. So if I have 19 students, I'm going to do 19 plus 1 divided by 2, which is 10. 20 divided by 2, so 10. So that means my median is hiding in 10 through the data. 4, 5. Well, I don't need to write this, but just to make it really clear. 10th place. There we go. That, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So my median is 10 through the data. So it is 55. Then my quartile 1 is a quarter of the way through the data. So that's n plus 1 divided by 4. So that gives me 20 divided by 4, which is 5. Let's just write 19 plus 1 divided by 4, which is 5. So 5th value, which is 47. And if you think about quartile 1, quartile 3 is just from quartile 1 times 3. So we take, well, not this value, but this value times 3. So we write it, often you see it like this, 3 times n plus 1 over 4. Let's write it like that for the brackets. So that means we have 3 times 5. So 15 through the data. So 11, 12, 13, 14, 15. It's 62. And we can double check, are we even on all sides? So let's say 62, we have 1, 2, 3, 4 on the side, and here 1, 2, 3, 4 on the side. So yes, we're balanced in the middle. Here we have 1, 2, 3, 4, and 1, 2, 3, 4. I know a lot of people also like to do it with their fingers, like you start at the end, and then you work your way up on the data one by one if you don't want to remember the formulas. Nothing wrong with that. That is also a fine method to do, to just go like you start here, and then inch your way until you get to your fingers meeting and joining in the middle. No judgment here. That's also a perfectly acceptable way of doing it, and often less mistakes, especially when you get funny values here, like 10.75 and stuff. Then that method's actually quite good because you can see what's in the middle. All right, there we go. We have our 5-number summary. So now let's plot it. So our data goes from 23 to 95. So I think I'm going to go in tens. 3, 4, 5, 6, 7, 8, 9, 10. Remember that ruler is really important. Well, I'm going to have to add one more, 0, 10. I could just start at 20 because that's my limit. Doesn't really matter. Very important to do the scale. Again, a lot of times I see scales just hanging in midair with nothing to hold them down, so you can't read anything valuable off of it. And let's go. Thank you for your question. I've just seen if they're asking for the range, well, range is going to be your maximum minus your minimum. So the same, I think that might have been for a question here. You'd have your minimum value, minimum value and your maximum value that you can read from your box plot or from your 5-number summary. So we'll write that up here. Range would just be 95 minus 23, our biggest minus our smallest. And interquartile range, going to be a quartile 3 minus our quartile 1. Right, so let's plot those. Just let me know if I didn't answer what you were asking, but hopefully that answered your question. And thank you for the question. Right, let's plot it. So 23 here, a little bit, doesn't have to be super accurate. That's like 25, so let's put 23 there. 47 somewhere here, 55 there, 62 here, and 95 here. All right, join up our box. Whoop. It's going to be, oh, that's all right. Okay, so it's a little more towards this side than this side. So that suggests that it is. We actually say, so it's more towards like the negative side. So we say it's positively skewed. Again, it's one of those weird ones, positively skewed. Because even though it's more towards there, we're actually looking at the tail end, just like the other question. Right, so there we have it. That's how we do our box plot from some values. Very typical question is to compare 2 box plots on top of each other on the same scale. So they'd be looking at the same variable. So oftentimes you're comparing 2 classes. Let's say we have a maths class of one teacher and a maths class of another teacher, and you want to compare the test scores that they got. You want to see. So if you had a look at this, which class would you say is doing better? Which class would you want to be in? Well, Class B. Class B is shifted a lot more towards the 100% than this one. Here, they're more gathered around the median, so the data is less spread out. So people tend to be doing around the same. It's much less varied, much less spread out, and it's a bit higher than this one. So when we get asked a question to compare 2 box plots, sometimes by just looking at them, you can tell. Think about what the situation is in real life. That helps you to answer it. And you can talk about things like this. The median. If the median is higher, you can say that this class performed better. If you can look at the interquartile box width, so how, like this box here, that's the box width, how wide it is. So for class A, it has 15 and class B has 10. So there's more variation. It's more spread out in this class. Well, actually, no, it says class A is, oh, no, it's the other way around. That makes sense, yeah. Because class A is actually this one. That's a bit confusing. And B is this one. This one is way more, the width here of this box is way wider. So it's more spread out. We can look at the range. Also, the range of values is wider. So there's more people doing not so good and It's more spread out. Sorry. And then symmetry. So is it symmetrical? Like a perfect symmetrical box plot would be one where all of these distances, I'm trying to draw this perfectly. It's not bad. Where all of these distances are exactly the same. That's symmetrical. Like if we had to fold it in the middle, it would be the same on either side. That's what we say, symmetrical box plot. Like this one is slightly skew. So these are things that we could use to look at for giving information about our box plot. Can you see my dog? He's just on the background sleeping. So if you hear any weird noises, it's him, not me. All right, let's do some exam style questions. So that is very small. Let me just zoom in on that. All right, a large company surveyed 160 of its employees. So already we know 160. That's our maximum, and it's going all the way up. So we don't need to worry about any values above here. It's at 160. And the results of how much time they spent traveling to work. So cumulative frequency, as you can see on the y-axis, and the traveling time on the x-axis. So let's answer some questions. Starting off with a nice and easy one. Find the median number of minutes spent traveling to work. So median number, we want halfway through 160, which is 80. 80, this is our median. So let's draw the line to our curve, and how nice of them, it's directly on a point. So we don't have to do anything crazy there. Also, a good idea is to really look at the scale of this. It's not going... like when you're reading off of it, you could even add some things if you think it's going to help, like 5, 15, 25, just to make sure that you're not reading off this wrong and assuming something with these gaps. There's something about this that's a little confusing. Okay, so it's at 40 minutes. So make sure you say the median amount of time spent traveling to work is 40, and then add your unit of measurement, minutes. They won't actually deduct a mark for that, but it's good practice, and you want the examiner to like you. Find the number of employees whose traveling time is within 15 minutes of the median. So within 15 minutes of the median, if I think about my median is at 40 minutes, within 15 minutes could be on either side, 15 that way or 15 that way. So we want to know plus 15, that would be 55, that's our new value, and minus 15, that would be 25. So within 15 minutes of the median is this interval here, between 25 and 55. That's what we want to know. So we need to read these values because we want to know the number of employees. So we're going to work backwards. So let's go at 25 and 55. Let's mark those off. So here's 55. We want to know there, and 25 is there. So let's read off 25. See, this is where we need to be exact. 25 is there, and that is going all the way across. There we go. And what are we working in? Well, that's 10. 1, 2, 3, 4, 5. So each one is 2. So that will be 18 there. Okay, so 18 employees are on the lower bound. 18 employees, and 55. That's all the way up here. Was that correct? Yes. So I'm just going to save some time there and not go all the way up. So that is there. Oop, excuse my line. Use a ruler if you have one, just to follow along and not make mistakes. That's 142. So between 18 and 142 employees. And they said the number of employees that are between that. So 142. 142 minus 18. 124 employees. Probably could have done that in my head, but just saving time. All right, so the number of employees whose traveling time is within 15 minutes of the median is 124. And that's a nice 3 marks for that. You'd get 1 mark for the that interval, 1 mark for reading off these values, and 1 mark for 124. Right, then only 10% of the employees spend more than K minutes traveling to work. Only 10%. What's 10% of the employees? So if we have 160 is our top amount, what's 10% of 160? This is a nice number. It's 16. I should maybe, well, I'm just going to say that's for red. That's my C. For anyone who wants these notes afterwards, I'm not doing a great job of making them nice. No, that was B. Try and make some order here. So 10% of 160 employees, that's 16. But we want more than K minutes. So we're looking at an upper question here. So if we look at 10%, like 16 here, that's not what the question's asking. It's asking more than K minutes. So we want the upper 10%, right? So 100 and, no, right in red. 160 minus 16 is 144. Yes. So we want when are 144 of the employees? When are what was the question of how much time they spend? They spend more than that amount of time traveling to work. So let's look at 144. That's 150 there. So 144 is there too. Oh, this is difficult. It's very small. Am I still on the right one? 142. No, 144. Ooh, I hope I'm still on the right one. Okay, there. So I'm going to go all the way down this one, and then it's 1 over. 1 over there. Okay, so that would be, we're going in ones here, 56. Be careful with these scales because the scale is in 2s, this is in 1s, so be very careful when you're reading things off. Okay, so at 144 employees that are in the top 10%, they spend more than 56 minutes getting to work. So K is 56. That was the value we were looking for. All right, very typical questions that will be asked. Right, then the question continues. Write down the value of B. B is our maximum, remember, from our box and whisker. Maximum, this is our median, which we found already. And this is our quartile 1 and our quartile 3 and our minimum. So they want the value of B, which is the maximum. Well, maximum value we had over here. Don't write 160 because that's cumulative frequency. But at 160, our maximum value is 70. It's super easy to write down 160 for this and forget that you actually were wanting in our variable. So 70 minutes is our maximum, our value of B. All right, the value of A is our quartile 1. Did we find our quartile 1? That was not our quartile 1. That was the question. So I'm going to just do it in another color for, let's do this. So A, quartile 1. Well, our median was at 40, it was at 80. So at 40 here. Sorry, with all the zooming in, it's like really small. And that looks like 31, 32, 33. So 33 minutes is our minimum. And the interquartile range, well, we don't have to read that off our graph because they've given it to us. over there. So that's really nice. So interquartile range, they saved us a bit of trouble, 47 minus 33. You could read it off your graph, but there's a chance that on your graph, you might read it slightly off. So it's better to use this information to be most accurate. And I think they might mention that in the mark scheme. So we have 44. No. Good morning. 14. Right. Traveling times of less than p minutes are considered outliers. Find the value of p. Now, even if this question doesn't make sense, like you're like, what do they want from me? What do they mean traveling less than p minutes? The key word here is outliers. So immediately, if you see the word outlier, apply the outlier formula. That's just going to definitely be part of the question. So we need the interquartile range times 1.5 to start our outliers. And then we want the lower quartile minus that value and the upper quartile plus that value. But they want traveling times of less than p minutes. So it's going to be this one, less than, not more than. So we don't need that one for now, less than. So the IQR times 1.5, what was our IQR? Interquartile range was 14. 14 times 1.5. So it's times by 1.5, we times by 1 and then by half. So 14 and then half of 14 is 7. So 14 plus 7 gives us 21. So interquartile range times 1.5 is 21. So the lower quartile minus 21 is going to give us our boundary for traveling times that would make an outlier. So lower quartile, we found that was 33 minutes. By the way, even if you got this value wrong, you can still get the full marks here for just using your value. So often in these A, B, C, D, E questions, even if you got a value wrong, for the next questions, it's okay. So if you're not sure how to find this question, you don't know how to answer this one, but you do know how to answer this one, really pick a random value. That's the some advice I can give you is just choose a number to use for this, apply the formula, pretend that was your answer for that one, and you could still get the marks here, even if you weren't sure how to answer that one and get it there. So it's the method that counts. So if you've said something here that isn't true, doesn't matter for this one, you've just got to use your value. So that would be 33 minus 21 equals 12. All right, so any value that is less than p is considered an outlier. That was my value of A. All right. Yeah, there we had 56, 33, and 12. Nice. Did I get IQR 14? Yes. Okay, good. A lot of numbers going on here. So let's have a look at this. Yeah, there is nothing crazy going on in the mark scheme. It's very straightforward. You get marks for your method and your answer. See, attempt here, what I was saying, attempt to find and their IQR. So that's super important. Whatever yours was, you get a mark. You get all the marks for that. You get a method mark, an A1 mark. Doesn't matter if your IQR was wrong in the next question. If you use it, that is your IQR, and you're not going to get penalized for using for like not getting the right value if your method is correct. Okay, so this is one of those questions I was talking about earlier. First, find the interquartile range. This is the easy part. So interquartile range is IQR is quartile 3 minus quartile 1. So quartile 3 is over here, 74, minus quartile 1 is 68, which is 6. There we go. Nice and very easy, 2 marks. One thing that I must say, don't just write 6. I know this is an easy calculation. You're just reading it off the graph. You get 2 marks. 1 mark for your answer, 1 mark for your working. So that would be a method mark, M1. That would be an answer mark, A1. So often I see people just jumping straight to IQR because they're like, oh, easy question. I'm just subtracting, done. If you want both marks, you need to show the method. Also, if you happen to subtract wrong, then you miss out on a whole 2 marks instead of 1. So as all maths teachers say, show your working, show your working, show your working. Now, this one, find the number of golfers that scored between 70 and 74. So between 70, what value is that? That's my median. And 74, that's my quartile 3. So how much data is in this part here between median and quartile 3? Anyone? What percentage of the data lies between the median and quartile 3? Exactly, 25%. Nice. So 25% of the data is lying between 70 and 74. 25%. And we have 80 people, 80 golfers. So what's 25% of 80? Well, it's just 80 divided by 4. Because 25%, if we divide it in 4, see, that's my dog. 25% of 80 is 80 divided by 4. Quick trick for dividing by 4, it's really nice. You divide it by 2 and divide it by 2 again. So half of 80 is 40, half of 40 is 20. There we go, 20 golfers. So this is an example of a question that a lot of students look at and they think, well, I don't have any numbers here. I only know the score that they got. I don't know how many golfers are here or how many golfers are here. So for that question, you just need to know the percentages of the data, that like 25% is there, 25% is there, 25% is there. Let me change the question slightly. Let's say it's between 64 and 70. So find the number of golfers between 64 and 70. So you think, okay, 64, I look at that, that's my, my minimum. And 70 is my median. Well, between my minimum and my median, that is 50% of the data. So 50% of the golfers is 50% of 80, which is half of 80. So 40 golfers scored between those values. Very common question that people get thrown off by, but it's actually quite easy. Right. There we go. Nothing crazy in the mark scheme. How are we doing for time? 2 minutes. Let's see. Maybe we can do one more. They might give you a table with intervals and number of performances, and there's a missing value. Well, we just need to know that the total amount should add up to 60. Look for those clues in the question. Another tip is to go and highlight in the question. Don't just highlight the number, highlight the variable as well. So it's 60 performances, because you might see 800 and think this has to add up to 800, but number of performances, 60 performances. Capacity, number of tickets sold is N, number of tickets sold up to 800. So then when you're trying to answer questions, it's a bit easier to go back. Bring a highlighter. I think I've said that every session, but bring a highlighter and a ruler to your exam. It's very useful. All right, so if we add all of these up, we need it to make 60. So we have 48. If we do that, 30 plus 18 is 48. Plus 3 is 51, so it's a missing 9. So we know that P equals 9. Then write down the modal class. So modal class, remember, is a whole interval, one of these. Which one has the most frequency, the highest frequency? Well, 30. 30 performances is the highest amount, so the highest amount of tickets sold. But we're not going to write down 30 because we want the modal class. So you have to write down the whole thing, 600 and 800, the whole thing. That's a nice, easy 1 mark situation. I'm not going to do that one because median, I think we're good with. Number of performances where at least 80% of the tickets were sold. So again, we want 80% of tickets sold, while on the x-axis we have tickets sold. So 80% of 800. So you'd work out 80% of 800. And then you could get the number of performances. So wherever that was, 80% of 100, I think is 640. Double check me if I'm wrong. And you would go 6, where are we? 1, 2. And you'd read off from your graph. I'm doing it a little bit roughly now, just in the interest of time. But then you'd see how many performances. So it's something like 36. 36 performances. Just a question of these percentages. So just make sure that you're finding the percentage of the right axis. Okay. Okay, so I was a little bit off because I'm doing it rushed, but it was 40, not 36. So if you read it off accurately, I think my line was a little bit, my line went a little bit crazy. But at 640, that's more like here. Whoop. At exactly, oh my gosh, that's terrible, but you get what I mean. So you need to be very exact. So not 36, but 40 performances. And it was at 640. All right, nothing crazy there. Okay, I'm over time, but I just want to do one more question because this is also one that looks like a complicated question, but it's not. So we have a box plot. I'm not going to go through the situation, but find the largest value. C is actually important. So let's go through this. The age of the adult A years old and of their eldest child C years old are recorded. So these are the ages of the eldest children. So adult A is the oldest. No. Ages. Okay, sorry, this is why I'm going too quickly through it. The eldest child. So we're looking at the eldest child, C, in this one. So C, their eldest child. I'm just going to write that there. Find the largest value of C that would not be considered an outlier. So we need to find a value that makes an outlier. Again, if you don't understand the question, the word outlier means we're going to have to do some outlier calculation. And we're doing eldest, we're wanting the largest. So we're not looking at the lower end, we're looking at the upper end. So that's the IQR times 1.5. And then we're going to add that to our quartile 3 because we're on the largest value on that end, not the, look out for words like that, not on the least end or smallest end. So from our box plot, we can find all of these values. So for that, I need my Q3. My Q3 is, there's my minimum, median, my quartile 1, median, and my quartile 3. So we have 10. My IQR is 10 minus 6. So the space there, my IQR, this box is always IQR, is 4. And 1.5 times my IQR is 6. 4 times 1.5 is 6. So I need to do my quartile 3, which is 10, plus IQR times 1.5, which is 6. So the largest value of C must be less than 16. Because once it is 16, it's considered an outlier. But we want less than 16. Not equal to, not C can't be equal to 16 because that would include it and that we've defined as an outlier. So for any value, C less than 16 and, well, we have, oh yeah, that would not be considered an outlier. Anything less than 16. All right, sorry, I rushed through that one a little bit just because I wanted to include it, but I hope that made sense. But the biggest thing is if you see the word outlier, the questions are often asked in a very strange way. And the most important thing is just to do the calculations, do the method. All right, there we go, 16. So some exam tips for cumulative frequency. That is a common mistake. Sorry, I should just write that. That's not a tip. A common mistake is plotting at the midpoint instead of the upper boundary. So remember, when you're doing cumulative frequency, plotting at the midpoint is a common mistake. You want to plot at the upper boundary. Remember that. Not the midpoint. Forgetting the starting point, remember that with a cumulative frequency of 0 and your lower boundary gives you your starting point for cumulative frequency. Joining points with straight lines is also a common mistake. You need to draw it with a smooth curve. And use a consistent scale on a box plot. So don't forget to do your scale before you do it. And memorize the formula for outlier. Okay, there we are. So as usual, notes are all here if you go to Exam Dojo Learn, and then all the notes by topic with all of the things that I covered today as well. There will be a homework assignment. I've just put up the one for session 5, which was yesterday. And so session 6 we'll put up straight after the session, and we'll be on histograms, cumulative frequency, and box plots. So everything from today. Class codes for that are on the info page. And if you have any other questions that you think of afterwards, or if you want the session notes or really anything, calculator help, you can find me on Instagram at Miss IB Maths. Just send me a DM and I will respond as soon as I can. I'm really happy to help. I know how stressful this time can be, and sometimes you just you have a question and you need it answered, and I'm happy to help out and send solutions or anything like that. So let me know. I also offer private tutoring if you wanted longer sessions. So any questions for now? The outlier formula is not on the formula booklet. So that was one of the ones that we had to memorize. Let me show you again the formula booklet. This is all you have. It's not a lot. The mean, like we were saying at the beginning, is not very helpful formula. So that just know that sum of all the values divided by how many there are. They give the interquartile range. That's it for this topic. So you need to memorize the outliers formula. Any other questions? Anything at all? I am going to put all of the sessions. Ooh, where are we? There we go. All of these session PDFs in one folder with more exam topic questions. So in one Google Drive folder, that will be easier, I think, for everyone to be able to, if you missed a session or want to check up, just to have it in one space. So also you can DM me with your email address if you want the link for that. Any other questions? All right, then if I don't see any, we can end there and hope that you have a lovely rest of your day. Good luck with all your studying. It's getting closer and closer. We have another session later today that is on trigonometric functions. That's for all courses, AA and AI. And then there's going to also be 2 sessions in the week this time. So we're getting closer to the exam, so we thought we would put more sessions in. So there'll be one on Tuesday and one on Thursday. And I think the one on Thursday might be exam strategies, but I'm not sure. It's all on the info page. So there we go. Okay, I'm going to stop sharing then. And thank you for joining. And yeah, maybe see you later. If not, good luck with the studying and have a lovely day. Bye.